Hello everyone, welcome to chemistry class. In this lecture, we are going to discuss the chemical properties of alcohols in which the breaking of carbon-oxygen bond takes place. So those reactions we are going to focus here. So without wasting our time, we are just coming back to the chemical properties. So we have reactions involving breaking of carbon-oxygen bond. So we have certain reactions in which the breaking of carbon-oxygen bond of alcohols takes place. So this breaking of carbon-oxygen bond basically defines the basic nature of this alcohol. So we'll take up reaction one by one. So look at this, reaction is with phosphorus halides. So reaction with PX3 or PX5, phosphorus trihalide or phosphorus pentahalide. Now this reaction already we have discussed while discussing the general methods of preparation of alkyl halides from alcohol. So again we are repeating the same reaction. So without wasting our time, so we have this. This is alcohol. These alcohols reacts with PX3 or red phosphorus plus X2. So whether we have this red phosphorus plus halogen or PX3, this gives you Rx. So if you look at this, 1 mole of PX3 reacts with 3 moles of alcohol to give you 3 moles of Rx plus H3PO3, that is phosphorus acid, is the byproduct here. So we have to focus on the byproduct also. Sometimes the question focus on what is the byproduct form in this particular reaction. So we have to know this is the byproduct from this PX3. Now reaction with PX5, phosphorus pentahalide, when this gives you Rx, so 1 mole of alcohol reacts with 1 mole of PX5 to give you 1 mole of alkyl halide plus 1 mole of phosphorus oxyhalide plus HX is formed. So look at this, there is a difference in the byproduct. Now there are some specific requirements for this reaction. So the points that we have to keep in mind is, for this, the reactivity order of alcohol, all this reaction takes place via substitution nucleophilic bimolecular reaction. So reaction is SN2. Now since the reaction being SN2, the reactivity order of alcohols is the primary alcohol is the most reactive, followed by secondary alcohol, followed by tertiary alcohol. So while carrying out this reaction, we have to very much sure that the alcohol that is used for this reaction must be primary, or in sometimes we can use secondary alcohol. So but don't take this tertiary alcohol. This reaction does not involve carbocation formation. Now since the reaction does not involve carbocation formation, no rearrange product so alcohols reaction with phosphorus halide, reaction occurs by SN2, that is transition state. Now since the reaction occurs by SN2 mechanism or SN2 pathway, the most reactive alcohol for this reaction, or the one which gives you the maximum yield of alkyl halide, will be primary alcohol. Now since the reaction proceeds via formation of transition esters, so there is no question of rearranged product form. So this is a reaction with phosphorus trihalide. Take this example. So we have CH3, CH2OH. Now this reacts with Pi3, phosphorus triiodide. When this gives you CH3, CH2I plus H3PO3. Take this reaction, CH3, CH3, CH2OH with TCl5. So when this gives you CH3, CH2Cl plus POCl3 plus HCl. So this is the reaction of alcohols with phosphorus halide. Then we have second reaction, that is a reaction with SOCl2, thionyl chloride. Thionyl chloride. Now look at this reaction of alcohols with thionyl chloride. ROH reacts with SOCl2 simply alcohol plus SOCl2, the product is RCl plus sulfur dioxide plus HCl. So these two byproduct, this is gas. But if the reaction is carried out in presence of pyridine, then the product will remain same. SO2 plus HCl, both this is gas. But there is difference in the mechanism. So this is in absence of pyridine, in presence of pyridine. In presence of pyridine, the reaction occurs by SN2, substitution nucleophilic bimolecular reaction, whereas in absence of pyridine, a reaction occurs by SNI, that is substitution nucleophilic internal mechanism, the mechanism which we have explained, which I have explained in the formation of alkyl chloride from alcohol. And by this method, look at this method, reaction of alcohol plus sulfur thionyl chloride to give you alkyl chloride. This is the best method for preparation of alkyl chlorides. The reason being, the byproducts sulfur dioxide and HCl is gas, so this immediately goes out from the solution, and no further purification or separation of the product is required. So because of this, the byproducts being gas, this is the best method for preparation of alkyl chlorides. So keep this thing in mind. Reaction, whether the reaction is carried out in presence of pyridine or in absence of pyridine, products are same. The only difference is the pathways by which the reaction takes place, that is different. In presence of pyridine, SN2. In absence of pyridine, internal mechanism. For this now, please refer to alkyl halide for the detailed mechanism. Now in presence of pyridine, this pyridine base combines with HCl to give you pyridinium hydrochloride. That means we have free Cl minus, and that free Cl minus attacks this intermediate form. So in this reaction, the intermediate form is ROS double bond O. So in both the case, this is formed. This further undergoes by internal mechanism or by SN2 mechanism to give you the corresponding compound. So this is reaction with thionyl chloride. So look at this. This being in SN2, reaction being SN2, if the alcohol is carried out in presence of pyridine, reaction being SN2, so these alcohol should be primary. If the reaction is carried out in absence of pyridine, the reaction occurs by SN9. So if the reaction occurs by SN9, there is the retention of the configuration. In this reaction, there is retention of configuration. In this reaction, there is inversion of configuration. So SN2, inversion of configuration. SNI, retention of configuration. So this is reaction with SOCl2. Then we have reaction with XX, hydrohalic acids. So when these alcohols react with XX, this gives you alkyl halide plus H2O. Now for this, look at this. The reactivity order of hydrohalic acid, HI is the most reactive, followed by HBr, followed by HCl, followed by HF. This is simply the acidic order. The reactivity order parallels to acidic order. Now, the mechanism for this reaction is different. If R is primary, if the alkyl group is primary, then the reaction occurs by SN2. But if R group is secondary or tertiary, then reaction occurs by SN1, that is via unimolecular substitution. So considering this, the reactivity order of alcohols is tertiary alcohol is the most reactive, followed by secondary, followed by primary alcohols. So this is the reaction. Again, this we have discussed for preparation of alkyl halides. Now coming to this, the mechanism part of this reaction. The mechanism part of this reaction. So look at this. First is XX dissociates to give you H plus ion and X minus ion. So this H plus ion will initiate the reaction here. So we have this RO. This oxygen of alcohol contains 2 lone pair of electrons. So this is acting as a basic site. So this reacts with H plus ion. When this gives you ROH2 positive. So this is base, this is acid, this is to give you this. If R is primary, then the reaction is, look at this, we have this ROH2 positive. This reacts with X minus ion which is present in the reaction medium. So this X minus ion attacks from the rear side and this leaves as the system as water molecule when we have this X and that is alkyl halide plus H2SO. So here the reaction is SN2. But if the alkyl happens to be tertiary or secondary, then what is happening is this ROH2, this breaks force giving rise to carbocation. So these carbocation R plus react with X minus and this gives you RX. So if the starting compound is chiral, then with SN2 there is inverted product will form, inversion of configuration. But with this unimolecular pathway, this is SN1, we have a planar carbocation that is formed. So this gives you 50% retention, 50% inversion. So we say racemization of the product. So depending on whether the alkyne is primary, secondary or tertiary, the reaction may be SN1, may be SN2, but the product will remain same. So this is the reaction with HX, hydrogen halide. Let me give you some examples here. CH3, CH2OH, this reacts with HI. So this is primary alcohol. So the reaction will follow SN2 to give you CH3, CH2, I. Take this CH3, CH3, CHOH, CH3. If suppose this reacts with HI, now read, look at this, this is secondary. As I told you, with secondary and tertiary, the reaction may proceed by formation of carbocation. So whenever there is a formation of carbocation, always look for the possibilities of the rearrangement. If there is a possibility for rearrangement, then the rearranged product will be formed as a major product. So look at this, when this reacts with this OH, this gives you secondary carbocation. Now this secondary carbocation will undergo hydride shift, and finally this is converted to tertiary, and the final product will be different here. So secondary carbocation rearranged to tertiary by hydride shift here. Take this CH3, 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 CHOH, CH3. If these reacts similar to the previous reaction, first secondary will form, secondary will rearrange by methyl shift to a more stable tertiary, and this tertiary reacts to give you the final product CH3, C, I, CH3, CH, CH, 3, this is CH3. So the formation of rearranged product is basically due to the formation of carbocation, and these carbocation rearranged to give you a more stable carbocation. If there is no possibility of rearrangement, then only one product will be formed, that is the major expected product. But if there is a possibility of rearrangement, then the rearranged product will be formed as a major compound. So we have this OH, this reacts with HI. Suppose we have look at this. This also contains. So look at this. This is reaction of alcohols. This is phenol. This is alcohol. So when this compound is made to react with HI, no reaction takes place with this phenolic OH. This only reacts with this alcoholic OH. So when this reacts, the final product will be CH2. I and OH remains intact. So this is the OH which remains as it is here. So this is reaction with HI. Now after this we have in this reaction, okay, let's discuss later on. Next reaction is dehydration reaction. Dehydration of alcohols. So means removal of water molecule from alcohol. So this dehydration, the reagent used for this reaction is concentrated sulfuric acid. This concentrated sulfuric acid is used as a reagent for dehydration of alcohols. Now look at this. We have this alcohol. This alcohol reacts with concentrated sulfuric acid. When this gives you two different products, so low temperature condition means temperature less than 140 degree. There is a dehydration, but this gives you ethers as the main compound. So this formation of ether occurs at low temperature, means temperature below 140. If temperature is high or under high temperature condition, that means temperature greater than 140 degree, this undergoes elimination and this gives you alkenes as the major product. So in both the case, water is removed, so reaction is dehydration, but the products are different depending on the temperature. Low temperature condition, ethers is a major product. High temperature condition, alkenes is the major product. Now formation of this alkene. For this formation of alkene, a reaction follows Saint-Jacques rule. That means the more stable alkene will be formed, and this alkene, the reaction follows carbocation. If the reaction follows carbocation, then the reactivity order is tertiary alcohol is more reactive, followed by secondary, followed by primary. So the tertiary alcohol undergoes most easily dehydration to give you corresponding. Okay. So since the reaction process by formation of carbocation, so the mechanism for this is E1 pathway, elimination unimolecular pathway. So whenever there is a formation of cation, the rearranged product may be obtained due to the rearrangement of carbocation. In this reaction of formation of ether, a reaction may follow SN1 or reaction may follow SN2. SN1 if the alkyl group R group is tertiary or secondary. SN2 if the alkyl group is primary or sometimes with secondary. So depending on the alkyl group of this alcohol, this may undergo SN1 or SN2. So this is how alcohols undergoes dehydration to give you alkenes. So now I'll give you the mechanism for this dehydration. And if you look at this reaction is a reversible reaction. Now we are following both. So take this. Suppose this is alcohol. This reacts with H plus ion coming from sulfuric acid when this gives you protonated alcohol. It is protonated alcohol. Now this protonated alcohol may undergo elimination of water to give you cation or may not undergo. So take this, let this be A. So we have to look at the CH, this OH2. So assuming that this is secondary or tertiary. If you are having secondary group or tertiary group, so this easily removes water molecules. So in the second step there is the removal of water molecules. So we say this is dehydration. When this gives you carbocation, so this is carbocation. Now this carbocation in the third step this is cation. Now this carbocation may undergo elimination of H plus ion. If this undergoes elimination of H plus ion, when this gives you alkene. So this is alkene, and all this reaction is a reversible reaction plus H2O, plus H plus ion. So again look at this. If we start from this alkene plus H plus ion, hydration of alkene, then this will give you alcohol. Dehydration of alcohol, alkene. So reaction is a reversible reaction. So we have to write down the mechanism for both. Both will be same. The only difference is for alcohol you have to start from this to this. From alkene, hydration of alkene, we have to start from this to this, this to this, and this to this. This is formation of alkene. Or if you look at this, we have this carbocation. This carbocation may react with this alcohol. So we have to look at this CHCOH. If this reacts here, CHOH, then this gives you ether, low temperature condition. So this is ether. Again there is a formation of H plus ion. So depending on the temperature, this reaction is favored at high temperature, this reaction is favored at low temperature. This is high temperature condition, this is low temperature condition. So look at it. If we have tertiary, then the reaction occurs here by formation of cation, and cation further reacts with alcohol to give you ether compound. But if the alkyl is primary, then this will give you protonated alcohol, and this protonated alcohol will react with another alcohol to give you ether. So this is the mechanism of dehydration of alcohol. So we have to be very specific about this temperature. So high temperature alkene, low temperature ether. Mechanism is different here. Elimination is E1. Substitution, this may be SN1 if alkyl is tertiary, SN2 if alkyl is primary. So look at this example. CH3, CH3, CHOH, CH3 reacts with concentrated sulfuric high temperature dehydration carbocation. So because of formation of carbocation, rearrangement takes place, and the major product is CH3, CH double bond CH3. That is the major product that is formed. Now if we have this, take this CH3, CCH3, CH3, CHOH, CH3. This reacts with sulfuric acid, high temperature when this gives you CH3 double bond C H3 CH3. This is the product. Carbocation followed by methyl sheet followed by elimination. So this is dehydration of alcohols. Next reaction, let's see. Next reaction is oxidation of alcohols. Oxidation of alcohols. First look at this oxidation with KMnO4, which is a much stronger oxidizing agent. So look at this RCH2OH when oxidized with KMnO4 acidified. This is primary. All primary alcohol on oxidation with KMnO4 acidic medium, primary alcohols are oxidized to corresponding acid. This is the final product, and Mn plus 7 changes to Mn plus 2. If we start from secondary RCHROH, this is secondary alcohol, a reaction with KMnO4 acidified, when this gives you ketones. So all secondary alcohols on oxidation with KMnO4 gives you ketone. In fact, with this primary, first oxidation gives you aldehyde. Aldehydes will further oxidize to give you corresponding acid. That is the final product. If we start from tertiary, this is tertiary. So tertiary with KMnO4 acidified, this does not give any reaction. But if the reaction is followed by heating, then this gives you a mixture of acids. So room temperature, no reaction. But if under the same reaction, that is KMnO4 acidified followed by heating, so this gives you a mixture of acids. So this is oxidation with KMnO4. Then we have a very important reagent that is known as dichromate. Oxidation with potassium dichromate with K2Cr2O7, potassium dichromate, chromium plus 6 in presence of acidic. Now this reaction, oxidation with potassium dichromate, this reaction can be used to distinguish between primary, secondary and tertiary. To distinguish between primary, secondary and tertiary alcohols. So let's start with primary alcohols on oxidation with K2Cr2O7 acidified. Now look at this K2Cr2O5, this is orange color, solution is orange color. So alcohol is colorless, alcohol plus dichromate, so this will give you orange color solution. Now the moment this reacts, this gives you all primary alcohol is oxidized to acid, and this chromium changes to chromium plus 3. So chromium in plus 3, this is green color. So if there is a change in color, then the alcohol is oxidized. So all primary oxidized to acid having same number of carbon atoms. So there is no change in carbon number. So same carbon number is present in the product. But there is change in color from orange to green. Green is due to chromium plus 3 state. So further we have to study this product. If the product is acid, then starting alcohol is primary. Take this secondary alcohol. This is secondary alcohol. As usual, this reacts with dichromate. So this dichromate is again orange color. Now secondary alcohol on oxidation gives you ketone. This is ketone plus chromium changes to plus 3. Again this is green. So in the second, again the same color changes observed, but the products are different. So we have to analyze the product. If the product is not acid, then the product has to be ketone, then the corresponding alcohol should be secondary alcohol. If the starting alcohol is tertiary, this is tertiary, Cr2O7 2 minus acidified. So this is no reaction takes place with tertiary, means there is no change in color when the alcohol sample is mixed with dichromate. That sample must be tertiary. If primary, if the color changes from orange to green, then the sample is primary or secondary. To differentiate between this primary and secondary, we have to analyze the product. If the product happens to be acid, then the starting alcohol is primary. If not, the starting alcohol is secondary. So this is how to distinguish between primary, secondary and tertiary. Now then, there are some mild oxidizing agents like PCC. This is a mixture of pyridine, HCl, Cr2O3, pyridinium, chlorochromate is a mild oxidizing agent which oxidize primary alcohols to the aldehydes only. Aldehydes will not be further oxidized. So if we want to restrict the oxidation products of primary alcohols to aldehydic stage, then we have to use this mild oxidizing agent. So by this, look at this primary alcohol on reaction with this PCC, pyridinium chlorochromate, primary alcohol is oxidized to aldehydes. So with mild oxidizing agent, the reaction stops as aldehyde. With stronger oxidizing agent, further aldehyde is oxidized to corresponding acids. So this is oxidation reaction of alcohols. Then we have next reaction, that is dehydrogenation reaction. So dehydrogenation means we have to remove a molecule of hydrogen. For this reagent is copper powder followed by heating. Again, this reaction can be used to distinguish primary, secondary and tertiary alcohols, because these gives you different products. So starting we look at this RCH2OH. This is primary. All primary alcohols on heating with copper powder, this gives you corresponding aldehyde. So hydrogen from OH and C is removed to give you aldehyde. If the starting compound is secondary alcohol, so on reaction with copper followed by heating. This gives you ketone. So secondary gives you ketone. But if we start from this tertiary alcohol of this type, this is tertiary, so these on heating with copper powder, these undergoes dehydration, that is a molecule of water is removed when this gives you alkene. So based on these products we can easily differentiate between primary and secondary and tertiary. If the product form is alkene, tertiary. If the product is ketone, secondary. If the product is aldehyde, then this is primary alcohol. So by using these we can differentiate primary, secondary as well as the tertiary alcohols. Now after this reaction we will discuss some chemical tests to distinguish between primary, secondary and tertiary. One of the method that we have discussed is dehydrogenation and reaction with dichromate. There are another reactions by which we can test these primary, secondary and tertiary alcohols. So the first test is Lucas test. The reagent used for this reaction is HCl in presence of zinc chloride. So HCl in presence of zinc chloride. This zinc chloride is used as a catalyst here. So look at this, we have started this RCH2OH, this is primary. So primary reacts with HCl in presence of zinc chloride when this gives you clear transparent solution. So reaction of a sample of alcohol with HCl zinc chloride, if the solution is clear transparent, then the corresponding alcohol is primary alcohol, because the primary alkyl chloride formed will be more soluble in the reagent. So because of this being more soluble in the reagent, solution appears to be clear transparent. But if we start with this secondary alcohol, this is secondary alcohol. So secondary alcohol reacts with this reagent ZnCl2 when turbidity or cloudiness appears in 5 to 10 minutes. So if turbidity or cloudiness appears in 5 to 10 minutes, then the corresponding alcohol will be secondary alcohol, because look at this will give you secondary alkyl chloride. So the secondary alkyl chloride is partially soluble in the reagent, but as the concentration of this secondary alkyl chloride increases, solubility decreases. Because of this solution becomes cloudiness or turbidity in nature. So this will take time. To within 5 to 10 minutes, if turbidity appears, then this is secondary alcohol. With this tertiary alcohol, reaction with HCl and zinc chloride, this turbidity appears immediately. if the turbidity appears immediately, then this is tertiary alcohol, because the tertiary alkyl chloride form will be very insoluble, means least soluble. So immediately the turbidity appears. So if the sample gives you turbidity, immediate turbidity, tertiary. If the solution gives you transparent color, primary. If turbidity appears within 5 to 10 minutes, then the sample is secondary. So by this Lucas test, we can distinguish between primary, secondary and the tertiary alcohol. So this is one of the tests. Apart from reaction with copper and potassium dichromate, we can also use this Lucas test to differentiate between primary, secondary and the tertiary. Then we have one more test. This test that I am going to give, that is a combined test for alcohol, alkyl halides and nitroalkanes. So the test is known as Victor-Meyer test. So let me write this. Victor-Meyer test. So I'll give you the reaction sequence. So we have this RCH2OH, this is primary. We have RCHROH, this is secondary. RCRROH, this is tertiary. So in the first step of this reaction, this reacts with HI. So the reaction of alcohol with HI, this will give you alkyl iodide. So if we start from alcohol, then this is test for alcohol. But if we start from the second step, that is alkyl halide, then this is the test for alkyl iodides. In the second step, this is reacted with AgNO2, silver nitride. When this gives you nitroalkane, RCH2NO2 minus AgI, this gives you RCHNO2, this gives you RCNO2. So if we start from this, then this will be a test for nitroalkanes. Then we react this with nitrous acid, HNO2. HNO2. Now when this nitroalkane is remain to react with nitrous acid, this gives you RCNO2 we get this is known as nitrolic acid. When this is made to react with this gives you RCRNO2 and the O. So this is known as pseudo-nitrol. So we have one hydrogen here, one hydrogen from nitric acid plus one oxygen. So we have this compound is known as pseudo-nitrol. Tertiary does not have hydrogen on this carbon, so no reaction takes place with tertiary. In the final step of this reaction, this is made to react with sodium hydroxide aqueous, sodium hydroxide aqueous, sodium hydroxide aqueous. Now this nitrolic acid on reaction with sodium hydroxide aqueous solution, this gives you blood red coloration. When this pseudo-nitrol is made to react with sodium hydroxide aqueous, this gives you blue coloration, and with this no color, or we say colorless. So if we carry out this reaction sequence, if the sample of alcohol by this reaction sequence gives you blood color solution, then the sample is primary. If the solution comes out to be blue color, then sample is secondary. But if solution is colorless, then this is tertiary. So this reaction is a very useful method for defining primary alcohol, secondary, tertiary, or primary, secondary, tertiary alkyl halides, or primary, secondary, tertiary nitroalkanes. So this is simply known as RPC test. RPC test. So R red primary, B blue secondary, C colorless tertiary. So we can just check out the color at the end of the reaction. So this is the test for alcohols. So this is some of the important reactions which involves breaking of OH bond, breaking of CO bond, oxidation, dehydrogenation, or dehydration reaction, or how to distinguish between primary, secondary and tertiary alcohols.